Hello, Keith Rucker here at VintageMachinery.org. Guys, today got a little rush job that I need to get knocked out for the Georgia Museum of Agriculture. They called me up the other day, and steam locomotive, the 1917 Vulcan Ironworks narrow gauge locomotive that they have at the museum, had a little problem. We had a part break on it, basically. And up in the steam chest, where the steam goes into the cylinders, there's a slide valve that slides back and forth as it goes down the tracks. And this is what is called a yoke. Some people call it a strap. The blueprints from Vulcan calls it a yoke, but it fits over the slide valve. I actually have the slide valve right here. It fits over it, and basically it just slides this back and forth and lets the steam go where it needs to go. Well, the yoke is broken, and we need to make a new one. So kind of got that taken apart pretty quickly out there, and I've already kind of got the ball started on getting a new yoke made. I had this one cut out of some steel, and this is what we're going to actually be making the new yoke and the new rod that's going to move this yoke out of. So let me kind of zoom in here, show you some of these parts, show you the blueprints we're working off of, and we'll get started on making this piece. I've got here a blueprint that we actually were able to obtain from the Pennsylvania Museum, Railroad Museum, or the Railroad Museum of Pennsylvania, I think is what it's called. They actually have in their collection all the original blueprints from Vulcan Ironworks, which was a Pennsylvania-based manufacturer in Wilkes-Barre, Pennsylvania. We contacted them several years ago, and they actually were able to dig up a bunch of blueprints for us and related to our locomotive. And I actually had this one already on my computer. So this is this yoke assembly right here that we are needing. And I did kind of go in and just blow that up, make it a little bit easier to see, since that's really the part on there that we're most interested in. Now, originally, when this locomotive was built, if you look in the materials selection down there, it will tell you that this part was one solid piece, and it was forged steel. So they basically forged this out. The rod here was turned to 1 1/16, it looks like. This was all one piece. Now, I can tell you that I've actually worked on these before. It's probably been 15 years ago now. And we actually replaced the rods on them. But when we took these out and replaced the rods, because they were severely eroded and corroded and needed to be replaced, at that time, they had already been replaced at least once before, because up here in the yoke, this was not a solid piece. They had bored out a hole here and basically put a rod in and pinned it in place to replace that rod. And I imagine that over the years that rod has probably been replaced multiple times. I know this will be the second time that I've done it, just in the time that I've been working on the museum, or working for this on the locomotive at the museum. Because it is steel, the original part up here, we just decided to cut it out of some steel. And then we're gonna, instead of making this one piece, we're gonna have it where the rod is removable and it can be replaced, because this is something that has to be replaced periodically as it's used. But anyway, this is what we're working off of, and let me kind of show you the original parts here. So this is the yoke, and I think this is the original yoke. It's marked R for right, and you can see what happened is basically right there where that rod goes in. It's fairly thin cross section there, and over the years it just snapped right there where that rod went in. The rod, this is the rod that goes in there. The last ones we did, we made out of chrome plated steel, because it moves in a packing gland, and that just kind of helps it slide in there better. You can see though that even though this one was placed, I'm guessing about 15 years ago, we already had some wear and erosion starting to happen in there. The rods that I replaced before, this area was just eroded all the way around and was probably 1/8 of an inch smaller in diameter, and it was just chewing up packing, wouldn't hold in there at all. So that was when we replaced and put these rods in. And when we did, again, we just used the hole that was already bored in there and repinned them in place, just like the original ones were. And I think we actually welded these on the end to give them a little bit extra strength when we did this one. but that's not really necessary, I don't think. So the new yoke, so this is the piece that we're going to make the new yoke out of. And this is actually just a piece of flame cut steel, 1.5 inches thick, which is what the parts are, what the design called for. And we had this cut out, CNC cut out, by some friends of the museum down in Valdosta, Georgia, Advanced Vessel and Alloy, a big shop down there that makes big pressure vessels and stuff. And they have big equipment, and this was no problem for them to put on their CNC machine that they have, huge machine that could cut through this 1.5 inch material, and this was flame cut. Now I will note, and you'll notice that these are a lot thicker around the outside edges. Because this was flame cut, they just couldn't cut it that thin. So we're gonna have to mill off some of these. The front side here I think is fine, but we're gonna have to mill off some around the outside here to get it kind of back down to the size. The inside is pretty close. It almost fits right over the valve right now. I'm gonna have to do probably a little grinding on that to kind of get it cleaned up. And again, I forget which grade steel he did. He told me they had several options, but they went with the one that was basically gonna have the most strength to it in this application. At least the engineer that I talked with down there, that's what we ended up going with. And again, I'm sorry, I don't remember which one it was. But this is what we're kind of starting with. Right now, I'm going to make the new yoke. I've also got to make the new rods. We've got some more chrome plated material coming in today that we will make these out of. And I think that instead of boring this out and pinning it in place, that we're just going to drill and we're going to thread that on there. I think that's going to be a little bit better way of connecting that rather than just a bored out. Also, this was bored out to 1 inch, and you can see it left a fairly small cross section. I think we're going to actually drill and tap this 3/4 inch, probably 3/4 inch fine thread, and we will screw that up in place. And that will make it easy when we need to replace these rods next time to just unscrew this, screw a new rod in, and without having to go through a whole bunch of trouble. That's what I'm thinking right now. All right, let's get to work. First thing I want to do is I'm going to take this back to my sander and just kind of clean it up, get the edges off of it, get the rust off of it, and then we're going to go to the milling machine, and we got to start milling these 3 of the sides to get them to size. That's going to be kind of our first step on this. All right, we're over here in the milling machine. Not crazy about this setup, but I think hopefully it'll work. We'll see. We're just going to start milling down this outside edge here. I just got a face mill set up, and we got this over in the vise. Let's see what we can do. Touch off on it. All right, let's see what happens. It didn't do too bad. Sounds like I got one tooth cutting heavier than the others on this thing. I might need to look at my cutter and make sure I got all my inserts set right. Let me mess with that, but we did get a good cut on that. That actually cut better than I was expecting it to. Let me play with this cutter for a minute though. So change in plans here. We're gonna actually, I think, try to do this over here on the horizontal milling machine. As I was running over there on the vertical with that thing sticking up and it was flexing and having to make very light cuts, I was sitting there, how can I do this better? And I got to think, I can put it on the horizontal, lay it down flat on the table, just clamp it down, put a cutter in the horizontal head, and I should be able to make much bigger cuts and get this done much faster. So that's kind of my plan. We're going to come in here and I'm just going to feed in until we start cutting there. Till we touch off. We're just running a face mill, as you can see. And I'm going to get that out of the way. Now I'm gonna feed in, let's see, that's 10, 20, 30, 40, let's just go about 50 thou here. And got my feed set pretty slow here. Let me speed that up a little bit. Again, sounds like I got one cutter doing most of the work, but you know what? We're gonna roll with it. It appears to be cutting really good. And I'm gonna figure out how much material we can cut off. Like I said, this is about 50 thousandths. I was doing 25 over on the other mill, and it's cutting that like butter. So we may even increase that depth of cut and get this knocked out. Looking back here, oh yeah, we're getting a nice finish on that. I think I'm just gonna let it roll like that. That seems to be working pretty good. I might be able to speed up my cutter speed a little bit, but I don't want to get too crazy. All right, we'll come back over. I'm gonna feed in another 50 thou. About 50 right there. Let it roll again. I did speed up my feed rate. We're at 5 7/8 inches per minute now. Still cutting just fine. I don't think I'm going to try to increase my speed anymore just to kind of keep the heat down. Ideally, we'd have coolant on this, but I don't have coolant set up on this machine right now. I need to do that at some point in time, but I just don't have it done. But this should make fairly short work out of this. We'll get this cut down to that thickness here in just a bit, and we got to do these sides as well, get those cut down. But this should go fairly quickly. We're hogging metal off. All right, we got the first, that back side there cleaned up. Now we need to get the other two sides here, these two sides. This side's gonna be able to kind of stay more or less like it is. But we need to get these thinned down on the sides. So I'm gonna just turn this 90 degrees. I will say that the alignment of these is not critical. You know, if it's not perfectly straight and parallel and all that kind of stuff. So I'm just laying these out. I'll tell you what, I need to go deburr that edge. There's the finish we got on it. Looks fine. I'm gonna take that to my sander and deburr that bottom edge so we can lay it down flat. But I'm just laying it out where the inside of this is just kind of parallel to the table. It's close enough. This outside diameter ring on this, no machine surfaces, it's just pushing and pulling a valve. So let me go deburr that. We'll get this one set up and we'll start thinning down these sides. All right, here we go. I got my part down on the table. Get to the other side here. I'm going to touch off. And I'll feed in another 50 thousandths. Right about there. And we'll let her rip. It's got that flame cut on that side, so it's wasn't a real straight cut, so this one's not really making a full depth cut. Just kind of cleaning things up. Next pass will be at full 50 thousandths. So I dialed in 50 thousandths, but just because of the angle on that, it's not making a cut all the way across. But all right, let me go see what this measurement needs to be. It needs to be considerably thinner than the other one. All right, the blueprint says 7/16, which is 0.4375. We're starting out at roughly an inch. So we'll make some more passes and we'll be back, but you kind of see the gist of things. Once we do this one, we'll flip it over, do the other side, get it thinned down, and have it pretty much done. We'll bring you back. All right, this should be my last pass on this side. Again, taking that one down to 7/16 of an inch, 0.4375. The measurement's not critical, it just needs to be close. Once we get this one done, I'm going to flip it around 180. We'll do the other side. I will note that I did stop, and I ended up changing out all the carbide inserts in that cutter. Some of them were chipped and not in very good shape, so I put fresh carbide in there. We still got one tooth that sounds like it's a little bit higher than the others, but it actually sounds a lot better, and I'm actually getting cutting on all the teeth going around. I can see the chips coming off of it. So I think we're a lot better. And I did speed the spindle speed up just a little bit. We went up to 214 RPMs. I still have my feed rate going at 5 7/8 inches per minute. If I were to go up the next one, it goes to 7 5/8, which it'd probably be fine, but you know, we're making a nice finish right now. I'm happy with where we're at. It's not taking long to get this done. We're just gonna roll on with it, so. Anyway, just bring you where we're at. We'll flip it around on the next turn here and get that one finished up. One more side to go. We don't have to do anything on this front side. All right, I got the other side cleaned up, and now I'm up on the very front up there. There's a little boss that kind of sticks out a little bit, and I just want to barely clean that up. We're going to be drilling a hole in that and tapping it, and I would like to have a somewhat square face for that rod to kind of go up against. So I'm just going to come in here, and I'm not going to take much off of it. I just want to barely clean it up. So we'll go across that front face. May have to make another pass. I'm just going to play it by ear here and get that cleaned up. You get this out, and then next thing I'm going to do is go to my belt grinder, and I'm just going to grind some radiuses on the outside edges of this, just to get some relief in there. Nothing to any real spec or anything. The drawing didn't even spec what that radius was. Just shows a radius on it. We'll soften them up and go from there. And I think we'll have the milling done on this. I think we got this new yoke pretty much made. Here's the original one, and just kind of laying it up on top of it. It matches pretty good. It had a little bit larger radius on these corners, at least on the back corners, but it's not going to matter for anything. But it looks good. I'm happy with that. And the biggest thing is this has got to slip over the valve. This is the valve that actually moves back and forth, and we got a really nice fit on that. Hardly any play in there at all. The original one, it was very worn. We actually had to put shims in there to kind of take some of that out. You want a little bit of play in it, but that's actually really, really nice. So we are ready now to work on getting our rod that's going to go in here. This is the original one. First thing I want to do is, like I mentioned before, is drill and tap a hole in here for the new rod to go into, and I think we're going to drill and tap that 3/4 inch fine threads. The fine threads are just a little bit stronger than the coarse threads, and that should give us plenty of room on either side of that, where it won't be as thin and weak in this area as the original one, which is 1 inch, and hopefully have a little bit more steel in there that will be less likely to break in the future. Of course, this one lasted over 100 years, so this one should be even better. Maybe. We'll see. All right, let me go get that hole drilled and tapped. All right, we are over here at the radial drill, and getting ready to line up on this hole. I just measured where we needed to be, and I ran a center punch on there to mark our spot. And I'm just getting the drill lined up above it. I'm going to start with a 3/8 inch hole, then we go to 11/16, which is the tap size for the tap we're going to be running. So let's run this down there first. Go through. Change out. Now we're going to drill this one through. There we go. All right, let's go tap it. All right, I've got a 3/4 16 tap in here, which is fine threads for 3/4, and I'm just going to put a little anchor lube on here for some tapping fluid. And we will go ahead and tap that in there. I've got my tap wrench in here with the tap follower to keep everything straight and lined up. And we'll just go down through there and put those threads all the way through. All right, it feels like we're coming out the bottom. Pull that up. Go ahead and just take that out. Won't be in the way. And we have our hole tapped. All right, I think our yoke is finished. Now we need to come up with the new rod. And again, we're going to make this out of some chrome-plated rod. Again, this goes through a packing gland, and that chrome in there really kind of helps it slide and stay tight. And we'll get rid of this area that has the steam has eroded away over the years. Like I said, these are kind of just things that have to be replaced periodically, these rods. Now, to make this out of, I've got some brand new chrome-plated rod. I ordered this from McMaster Car. It's 1 inch diameter. I know our blueprints calls for 1 1/16 inch. On the rod, the thread is 1 inch, but the rod called for 1 1/16 inch. We've always had 1 inch rods on this. I don't know whether that was just changed from the original, but that's what we're going to go back to, is just a 1 inch rod. So we'll just make this the same length. I'm going to go cut this off, probably just leave it in this wrapper stuff to protect it. But we'll cut that off, and we're going to thread both ends of this over on the lathe, and we should have this thing ready to roll. All right, so we need to put some threads on here. This first side, 3 1/4 inches from the end, needs to be 1 inch, 8 threads per inch. So I'm going to start by facing the end of this, and then we will go in there and thread it. So let's fire up the lathe. This is the side we cut with the bandsaw. I think I am going to put a center on this just because this chrome is really hard. Chrome plating on the outside, that layer is really hard, so I think a center will just kind of help us keep it from flexing a little bit. Our threading tool in here, we're going to pull that back out. I got a line on there where we're going to thread to. Start by chamfering this edge over here where with the lead end angle of the threads. Go. A little bit of run out, but no big deal. Let's see where we're at. Just make sure we're on 8 threads per inch, and we are. getting close to being on size here. I will admit here that I have been struggling a little bit getting this to cut because it's just such a hard material. But I did change my tool. I went to this lay flat tool that is working better than that stand-up tool. It doesn't like it. It's fussing as it goes down through there, but we're getting it cut. Just taking out a little bit at a time. And I just tried it with a bolt a minute ago and it wouldn't quite start up on the end. For whatever reason, this end seems to be a little bit harder than the rest of it too, which I think is impacting me here. All right, I'm gonna feed in just a couple of thou. Make a scratch pass, not feeding in at all, just going right back down the same path we just went, but there's so much flex in these tools that it's still cutting. All right, let's do another test fit here, see if we can get a nut up on it now. I think we're good. It's a little bit tight getting started, but once we kind of get up on there, it loosens up. We can make it work. All right. Man, this thread has fought me the whole way, but and it's just because it's hard. This chrome-plated stock is just really, really hard, and dealing with it can be aggravating sometimes, but I think we got it. All right, we have our rod turned around the other side now, and this side needs to be threaded out at 3/4 inch fine thread, whatever that is. But I need to turn this down to 3/4 inch first. So again, we got some really hard material here. I'm hoping that we can kind of get underneath that chrome layer and get it off. I'm going to turn my speed down a little bit. Got a pretty coarse speed rate, but it'll be all right. I'm going to be threading over that anyway. Leading edge up there, chamfer that. I'm going to go ahead and just break this corner here a little bit. All right, we got 16 threads per inch dialed in. And I'm just going to make a scratch pass here. That looks good. All right. Let's cut those threads. I'm going to slow it down just a bit here. Let's see where we at. All right, guys. I think I missed a little bit of my single point threading here on there, but we did thread this down. And then what I did was I took a die, 3/4 16 die, and I ran it up on here and just made sure that everything was cleaned up right to size. So we've got our threads cut. We're ready to take this out and go do a test fit. All right, we have our yoke, we have our rod. Let's see how this fits. Oh yeah, that's nice. I think I'm going to put some Loctite on that just to make sure it doesn't come out. I've got some Loctite 290 thread locker here. And we'll put all this together. And just like that, one new steam chest yoke, right made to the blueprints. This is ready to go back together in the locomotive. I'm going to take it out there in the morning, let them go ahead and get it put back together. I don't know if I'll get any video of that or not. I'll try, but I'm not going to make any promises. Just depends on whether I have some time to go out there in the morning and help them, or whether they're going to have to do it on their own. But we are ready to send this on. We got this made. Well, there you go. One more steam locomotive part ready to go. This will move this valve back and forth. Hopefully it'll last another 100 years. Hopefully the next person that has to make a new one won't be me. Although I am going to be making a new one, another new one. I actually had an extra blank cut out when we had this one done. And I've got enough rod here to make a second one of these. And my plan is this summer, when we have time for some, when the museum's closed for a month in August and we have some time to do some maintenance, I'm probably going to go ahead and make another one and just go ahead and swap out the one on the other side. I know that the rod is in need of being replaced on the other side as well. And while we're at it, we're just going to go ahead and put a new yoke in there, one that'll be easier to change these rods out in the future. And I think I'm also going to draw up a blueprint for this rod and let the museum put it in their file, so that should something ever happen to me and they need to make some of these down the road, they'll have the specs on how to do this without any problem at all. So anyway, there you go. That's going to be a wrap, guys. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And as always, a big, huge thank you to those who support the site financially through Patreon, PayPal, etc. It enables me to take the time to be able to shoot these videos, edit the videos, and everything that goes along with that, which takes a lot of time. And with that, guys, we'll sign off. Catch you on the next video again. Thanks for watching.